Okay, I am running. Oh, technical difficulties here. I think this is the last identities note, and here again are the last of this year's identities. Remember that there were 17 in the previous note at the very beginning of this unit. The 17 there didn't include double angle identities or compound angle identities. These ones do. So if I separate them for you, above this yellow line are the double angle identities because they all have these twos, two angles, two angle, two angle. And then if you look below, those are the compound angle identities, and the compound angle identities are where you make combinations with adding and subtracting, either for sine, cos, or tan. And we haven't covered the red ones yet. We will do that, but I just want to continue with these ones, meaning the double angle and compound angle identities for cos and sine. So I do want you to know that when you tackle these questions, I believe you should know these questions are these kinds of questions because you have this kind of stuff. So if I flip to the second question, there it is again. So we'll talk about that in a minute. I'm going to put this on normal screen, and then I'm going to take us back a slide, and let's talk about that stuff. Big eraser. So I did write these questions in radians, not that it matters at all, but this information tells you that angle A, which is a completely separate picture to angle B, angle A is between 0 degrees and pi over 2, which is 90 degrees, and you can check that on your unit circle if you like. When we get to angle B is trapped between 180 degrees and 3 pi over 2 is 270 degrees. So what I'm going to do is I'm going to draw the pictures. I'm going to do this one in red, and then I'll dig out the blue pen and we'll take care of this. Then we'll take care of the determining the exact value of these two pieces of information. But before you even think about that, you need to translate the red and the blue segments. So, because it talks about this kind of thing, that means I'm going to dig out a grid. Now I've drawn all four quadrants, one of them better than the other, and the one I focused on was the 0 to 90 quadrant. And I'm going to put a terminal arm representing angle A, and then I'm going to draw it to the x-axis like we always do. And then I'm going to dig out the red pen because I said I was going to do this in red. And there's the right angle. This is angle A. Dig out my green to say this is opposite, this is hypotenuse, this is adjacent, in case you need those markings. So I've taken care of this part. Now I have to take care of the fact that sine A, the sine of angle A, is equal to 12 over 13. And that is opposite over hypotenuse. So with my red pen, I'm going to put 12 for the opposite and 13 for the hypotenuse, which means I have no idea what the adjacent is. So I'm going to do the adjacent information here. I'm going to drag it below eventually so that I can still look at my instructions and talk about B when we get there. So I'm looking for a non-hypotenuse. 13 is the hypotenuse. Remember, the hypotenuse is always positive. So 13 squared equals, I'm going to say x squared because it's a sideways movement that I'm looking for, not that it matters of your letter choice, plus 12 squared. So it's 169 equals x squared plus 144. So 169 minus 144 is equal to x squared. And technically x squared, because it is a directional movement, could be a plus or minus. Oops. Skipped a step. 25 equals x squared, which means x is equal to plus or minus 5. Now, we're trying to determine side lengths and also direction, so I can say that this is positive, and I can say that this is positive. That's up, that's the hypotenuse, and this is also positive because I'm moving to the right. So back when we were talking about exact values for points, this is a right up movement to get to this corner, so both of those are positive. And now what I'm going to do is I'm going to group all this stuff together, and we have all the information laid out that's necessary for picture A. Now, that doesn't mean I know what the question is, and all this pre-work is actually pretty important, but we will get there eventually. There we go. All right, now I'm going to go back up, and we're going to talk about the second piece of information. So I'm going to draw a grid again. And this time it's between 180 and 270, so I'm going to focus in there because that's 180 and that's 270. And you can check your unit circle for that. So I'm going to draw my picture in here, and as always, draw to the x-axis, so I'm having 1/4 of the bow tie. So this is blue. Blue is B, and we have a right angle triangle. Back to the green pen in case you need opposite, hypotenuse, adjacent. I've given you tan B is equal to 24 over 7, and tan is opposite over adjacent. So with my blue pen, for the opposite, I can say this is 24, and for the adjacent, I can say this is 7. Now, I don't know if you can tell, but this is a left down movement, so this is actually a -7, and this is a -24, and those two negatives cancel out and become a positive, which is why you don't see them in this fraction. What I need to do is I need to find the hypotenuse, which is always positive, so I'm going to do all my work over here, and I'm actually going to keep it there because I have space. So we have that, so h squared is equal to -24 squared is 576 positive, plus 49, and when you add those two things together, you get 625, and technically when you take off that little 2 and square root, you should get plus or minus 25, but when we go to label the hypotenuse, it's a positive because, as I said, hypotenuse is always positive. It doesn't represent a direction, it just represents a length. So we have all that information. So let's see if I can scale this back just a little bit and fit everything in. This blue rectangle isn't important anymore because we've got what we needed. And now we have the picture. The picture is what we will continually look at. And this red stuff also isn't important anymore. What we care about is the picture. That's what we will get all our information from. So I'm just going to move them slightly down a bit so that I can see them as I'm working on questions A and B. So A first. When you look at this statement, I hope you think, oh, that kind of reminds me of a compound angle identity that I should be using. And it should make you think of this one. So when you have cos of two angles being subtracted, you end up being able to stretch it out with this right-hand side. So cos cos plus sine sine. And I'm going to do this work in black because for the time being, I don't need any color coordination. So cos cos plus sine sine. So now what I need to do is I need to use these two triangles. Here's the A triangle. Well, where I will replace cos A, and I will replace sine A, and then we have the B triangle where I will replace cos B and I will replace sine B, and we'll be giving those same fractions but not unit circle fractions. Instead, we are based on these triangles, and in between is a plus sign and at the beginning is an equal sign. So you can do this in whatever order you want. You can find cos A. So cos A is adjacent over hypotenuse. And then if you want to, you can skip to cos B. So you go over here and do adjacent over hypotenuse. Plus sign, go back to the red if you like, or you could do all the red at the same time and slide them in where they belong. So sine A is opposite over hypotenuse, and sine B is opposite over hypotenuse, so negative 24 over 25. And then you do the same thing as we did before, and that is you multiply across the top, multiply across the bottom, multiply across the top, multiply across the bottom. So I'm going to do this in black because I've got all my information. So this is negative 35, 5 times negative 7, over 13 times 25 is 325, plus 12 times negative 24 is negative 288, over there's 13 times 25 again. Do not be surprised that it's common denominator already. So I'm not going to write negative 35 plus negative 288 all over one big 325. I know my answer is all over 325, but I need to figure out what negative 35 plus negative 288 is, and that answer is negative 323. And as long as this fraction is reduced, we're done. We have the exact value of this combination. So now let's do it again, only let's do it for sine A plus B, which means you should still recall that there is a trig identity that kind of looks like that. So this one is sine, cos, cos, sine. Sine, cos, cos, sine. And then you can go looking for your sine of A and your cos of A and your cos of B and your sine of B, and you can input them into those brackets. So sine of A, go over to the A picture and do opposite over hypotenuse. If you want to, you can do the cos of A at the same time, adjacent over hypotenuse. I'm going to do that so I can keep my red pen out. Switch to blue for me. Cos of B, so go over to picture B and do cos, which is adjacent over hypotenuse. And then the sine of B, so still on the B picture, sine is opposite over hypotenuse. And then just like before, multiply across the top, multiply across the bottom, multiply across the top, multiply across the bottom. So 12 times negative 7 is negative 84. 13 times 25 is still 325. Plus 5 times negative 24 is negative 120. 13 times 25 is still 325. I've got a common denominator of 325. I need to make sure that I figure out negative 84 plus negative 120 is negative 204, and as long as both of these are reduced, we're good to go. Now, I feel like I've made a mistake here, so give me a sec to check my math. So my numbers are okay. 12 times 7 is 84. 5 times 24 is 120. I'm checking to see if anything divides into those two. Nope, I'm good. I thought this was reducible, and a lot of times with cos and sine it is not. So we're good to go, and that's done. So if this is reducible, if you can divide both levels by the same number, you must continue. And that is the exact value for this. So it's a ratio. It's one number over top of another, representing opposite over hypotenuse of the two angles being added together. So that was using compound angles. Let's do one for double angles, and we've got that same stuff. So I'm going to erase that stuff that tells you it's one of these questions. And then I'm going to translate. And again, I'm going to keep with my color coding. So I'm going to do red for this stuff, and blue when I switch to picture B. I'm still concerned about exact value. And with my green pen, to translate this in case you need a hand, 0 to 90 degrees. Pi over 2 is right on your unit circle, so you can check without converting. And this one is 90 degrees to 180 degrees. So again, I have to take these things out of the way and pre-draw my triangles. So first one, I can draw the axes right in the center, or I can focus, troubles here. Or I can focus on the quadrant I need to, which is the 0 to 90. Put in some terminal arm. Draw a quarter of your bow tie. Okay, that's not straight, but it's a doodle. 90-degree corner. Picture A. So this is opposite. Nope, it's not. Adjacent over hypotenuse. Opposite. Hypotenuse. Adjacent. Red pen. 1 over 4. So we need to figure out opposite, which is a non-hypotenuse. I'll do it here and then scale it back a little bit. Hypotenuse squared equals up and down squared plus the other one squared. So that's 16 equals y squared plus 1. 16 minus 1 equals y squared. 15 equals y squared. And y would be equal to plus or minus the square root of 15, which is not pretty and also not reducible. So I do have to worry about that reduced radical form stuff. And I'm going to put this here for the time being. I'm also going to dig out the red pen again and say that this is positive root 15 because it's an up movement. So this is right, so we're good, positive. This is up, so we're positive. Hypotenuse is always positive. Now it's time for the blue pen. So the picture has to be drawn between 90 and 180. So that looks good. Right angle, B. Sine is opposite over hypotenuse. Opposite, hypotenuse, adjacent. So that's 1 over 3. Positive, we're good. Up, positive, we're good. Let's find the adjacent. So 3 squared equals x squared plus 1 squared. 9 equals x squared plus 1. 9 minus 1 is equal to x squared. So that's 8 is equal to x squared. So x is equal to plus or minus the root of 8. Just to remind you that all the math eventually has to fit together. So root 8 is root 4 times root 2, 4 being a perfect square. So we can reduce this radical to x is equal to plus or minus 2 root 2. When I go to the picture, it's left. So I have to pick the minus 1 to make the picture accurate. Scale this back. And let's look at A first. So, this is asking for the cos of 2a. So these questions, unlike the previous ones, do not mix the A picture and the B picture. This one is all about A, all about B. The only problem is you have 3 choices. It doesn't matter which one you choose. I'm going to pick the top one. So my choice is cos squared A minus sine squared A. I'm all about picture A. So first of all, cos A is adjacent over hypotenuse, and it needs to be squared, minus sine A is opposite over hypotenuse, squared, 1 squared, 4 squared, root 15 squared, 4 squared. I've got a common denominator of 16, so all I need to do is the 1 minus 15, which is negative 14, and then unfortunately we have one last little bit of work to do, and that is because both of these are divisible by the same number, you have to reduce your fraction and you're done. You might like this question a little bit better because even before I flip, I know there's only one choice, and this one choice has no adding and subtracting in it at all. It's just finding the parts and multiplying them together. So the 2 will stay 2, and in case you're wondering where I got that from, here but B's. The 2 will stay 2. The sine B is picture B opposite over hypotenuse. Cos B is picture B adjacent over hypotenuse. And then to stay consistent, I'm going to put this 1 down and multiply across the top, multiply across the bottom. So 2 times 1 is 2, times negative 2 is negative 4, root 2 beside it, and then 1 times 3 is 9, and because the non-root portion of this is not reducible, we get to stop in this question and we're done. So that is the end of what I'd say are the typical sine and cosine compound angle identity questions that are not proving left side equals right side, and also the double angle ones. What I want to do now is I want to focus a little bit of attention on the double angle for tan and or the compound angle for tan. And you can tell that tan is still not friendly. Your sines and coses are so much better, even here. So here's a question. I'm going to take a little break for the hand cramp again, and I'll be back shortly. Okay, pressure's on because I just realized I don't have a unit circle here, so I'm going to kind of freehand unit circle, or at least the information I need. So with this question here, I hope that you look at this and you think at least that looks like a compound angle. And then because I've got my tan information sitting here, I hope you match it up with this third one, which is two angles being subtracted. This is a prove left side equals right side question, so one thing I wish I'd done that I did not is do this. And oh, now I know why I didn't. I'm not going to write this down. I'm going to write the equivalent with the pi and the x in the right spots, but this version. So tan of x, which is the first entry, so pi, minus tan of the second entry, which is x, over 1 plus tan of the first entry times tan of the second entry. Now I am going to move b out of the way. I need room to scribble. In addition, I need room for my left side, and I know I've been telling you to please take your, my right side, to please take your information and turn it into sines and coses, but I'm going to leave it like this for now because that's got a whole lot of tan, and I don't want to be changing all these into sines over coses, so I'm not going to change that quite yet. I can backtrack and do it at any time. What I don't know off the top of my head is what the tan of pi is, and that's because I don't have a unit circle. So I'm going to draw what I need, as in pi is sitting over here, and that is a pretty easy coordinate to find because it's -1 out, 0 up in the air. And remember that this is cos theta first, sine theta second. So you don't always have to draw the entire unit circle. I need sine pi over cos pi to replace tan pi. So that ends up being 0 over -1, which is 0. So all my little scribbling on the side lets me take this quantity right here and just turn it into a 0. Minus tan x, which I can't do anything about, over 1 plus, there it is again, 0 times tan x. So 0 minus tan x is just negative tan x. So I'm on the right track. How are your 0 times tables today? 0 times tan is 0. So I end up with negative tan x over 1, which is negative tan x. No surprise. Left side equals right side. Happy face. So now I'm going to do the second one, which doesn't look so pretty. Left side equals right side because it's a prove question. And I'm going to leave my right side this way because I certainly, at this point, until it's absolutely necessary, I do not want to turn tan into sine x over cos x and make 4-level fractions. If I can avoid that, I will. So I'm going to see what happens on the left side, which looks very compound angle-like. And if I reach up here, and I can drag this down temporarily, I can steal that bottom one again because this is a tan of subtraction. So red pen, tan of the first entry minus tan of the second entry over 1 plus tan first entry tan second entry. So I'm going to need that space. I'm going to pull that back up again. So I've got what I need, and now I can focus on this. So off the top of my head, that's 45 degrees. So when I doodle what I need to from the unit circle, I care about that one. And that's the one I have a lot of success remembering. I remember that the coordinates for 45 degrees are root 2 over 2, comma, root 2 over 2. And you can check your unit circle if you like, because you might have yours handy. That means if I want the tan of pi over 4, that's the same thing as the tan of 45 degrees, which is the sine of 45 degrees over the cos of 45 degrees, which means, saving myself a little bit of writing, it's the second entry over the first entry, but because they're identical, that will be a 1. So I can turn this whole thing into a 1 minus tan x over 1 plus, I can take this whole thing and turn it into a 1 tan x. Gaze lovingly at your right hand side. The top is identical, so that's pretty exciting. You do not do 1 plus 1 is 2. You do multiplying first, so 1 plus the result of this is tan x. No coincidence that they are now exactly the same. Left side equals right side. Happy face. So a little bit of a break, and I'll check out the rest of this note. Alright, I don't know if you noticed the change I made, but I gave in and grabbed my unit circle. When we do this question, I want you to know that there is a hard way of doing the question and an easy way of doing the question, but you never know until you get into it, and that is a bit of a problem and a bit of a frustration. But let's start it and see how we go with this. So this is actually a question that we've kind of done before, because if you check your unit circle, 165 degrees is nowhere on it. So this is the stuff where you had to take two numbers from the unit circle and you have to make 165 degrees. So don't write all this stuff down, because I may pick bad. So I think the one I used before was 135 degrees plus 30 degrees. And I will know momentarily whether or not this is a good pick or whether I need to re-pick. Know that any multiple of 45 is a good pick. It's the other one. So I'm going to check the tan of 30 degrees, and then I'll show you why things are good or things are bad. And I'm going to do the tan of 30 degrees over here, and then I'll tell you why, but I'm going to do the pre-work right here. So tan of 30 degrees is sine of 30 degrees over cos of 30 degrees. So I've got 1 over 2 divided by, so that's sine, root 3 over 2. So 1 over 2 times 2 over root 3. Gone, gone. 1 over root 3. Bad pick. And the reason it's a bad pick is because we came up with a fraction, and I want to avoid any fractions. So that means this one will be a fraction, and I should probably go with something that is not here, or here, or here, or here. So I don't want to pick 50, or 150, or 210, or 330, because it'll give me some positive or negative value like this. So let me show you in a second what'll happen when you re-pick. But re-picking means changing our numbers. I still like plus better than minus, and it doesn't matter the order, but 120 plus 45 is another value for 165. Remember, the 45 multiples are okay. 120, let's check where that is. It's here. Okay, that's a good one. So let me show you what I mean after we tear this apart and turn it into this guy. So tan of 120 degrees plus tan of 45 degrees, first, second, over 1 minus tan of 120 degrees, tan of 45 degrees. So if one of these was tan of 30, like I had, you would be turning this into that, and then you'd have a 4-level fraction, because you'd also be doing that here, and I want to do everything I can to avoid that. And I'm telling you that all the 30s, as in 30 off of each x-axis, is bad news, but 60 off of each x-axis is not bad news. So I'm going to erase, actually no, I'll just leave it. I'm going to do the tan of 45 degrees, because I need it in this space. The tan of 45 is sine of 45 degrees over cos of 45 degrees. So that's root 2 over 2 divided by root 2 over 2. I can flip and times, or I can realize that anything divided by itself is 1, or even better, I can realize that I did this question already. So everywhere there's a tan 45, I can replace it with a 1. That's a pretty good deal. I now need to figure out the tan of 120. So going through the exact same steps, tan of 120 degrees is equal to sine of 120 degrees over cos of 120 degrees. So sine is root 3 over 2 divided by cos is negative 1 over 2. Flip and times. Doesn't matter where the negative goes. 2's will cancel out, and you'll be left with root 3 over 1, but it's negative, so there. So everywhere I have a tan 120, I put a negative root 3. Everywhere I have a tan 45, I put a 1. So let's see if I can retain that. Negative root 3 is the tan 120 replacement, plus tan 45 is 1, over 1 minus, there it is again, negative root 3, there it is again. So notice how I don't have 1 over root 3, which was really bad. Make this look pretty. So I've told you before, I don't like starting with negatives, so I'm going to flip this around, not that it matters. 1, that is itself, times another negative is a positive, and we get this answer. And yeah, that's a pretty uncool answer, back to the we don't like roots in the denominator, but I'm going to leave it. It's an exact value. I'm happy at this point. If at some point you want to know how to fix this, I will help you with that at a later date. So let's try this one. So I can't do this question. And the reason I can't do this question is not because I can't do it at all. It's that I can't do radians. My brain doesn't work in radians. So I have to convert. So 180 times the 13 divided by the 12 is equal to 195. So I can replace that with tan 195 degrees. And then I have to find two numbers that add or subtract to 195 that are off the unit circle. And again, a reminder, don't pick one of these guys. you create awfulness. So, again, 195. That'll be 30 plus 165. 165 is not on there, even though 30 is, and I told you to avoid this. So repick. $135 plus 60. Remember, your 45s are always good. 60 is good enough. So let's try this using the exact same information as before. This is another plus, so I need to make that just visible. Tan 135 plus tan 60, all degrees, over 1 minus tan 135 times tan 60. Now the only thing that's wrong with this is that I have to start from scratch. So let's start from scratch. Which one do you want to do first? I think I'm going to do 135 first. Tan 135 degrees is equal to sine of 135 degrees over cos of 135 degrees. Sine is the second one, divided by cos is the first one. Those are identical values, except one of them's negative, so this answer is a -1. And then the other number I chose was 60. And at some point, if you feel like skipping steps, you can, because this is just generating information for a larger question. So sine of 60 is off the chart. Sine is the second one, so root 3 over 2 divided by 1 over 2. Flip and times, knock out the 2's, root 3 over 1. So you get repetitive values again, because guess where you're getting these numbers from? The very repetitive value unit circle. So -1 for every tan 135 and positive root 3 for every tan 60. Let's see if I can retain that. -1 root 3. 1 minus -1 root 3. And this is negative times that is positive. So you can leave it like this. You could swing that around like I chose to do here. It's totally up to you. What you cannot do is go bam, 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 bam. You can't do that because you can't cross out anything over addition. You can only cross out over multiplying and dividing, which is why I could get away with it here. There was no addition and subtraction in that spot, so crossing out was legal. Same deal here. So don't do it when you get to the end of these tan questions. All right, blank spot, the end. Done trig identities, except your turn. See ya.